All right, Liana, right now you're the only student in the office hour. So if you had any
Okay.
specific questions,
Yeah, actually, since no one else is here for recitation, do you mind if we go over one example from the lecture slides before we start the recitation?
oh yeah, yeah, I'm fine with that.
Okay, would I be able to share my screen? That way I can really show you which one or
Sure, let's do that.
okay.
I'll stop sharing then. And then we can go, let's see. Okay, you should be able to go now.
Okay, let's see. Okay, let me know if you can see it.
Yes, I'm able to see it.
All right, I was just really confused with this example. So I was trying to do one of the concept quizzes yesterday, and there was a similar question, and I was trying to solve that question based off of this example. And I don't think I understand it really. So all I understand so far is, of course, the frequencies that we are given for island one and island two. And then I understand that we did the average,
Okay.
but I just don't know what we're doing after that.
So honestly, I'm not too familiar with these specific equations. And if I remember
Okay.
correctly, the previous exam, so the main equation that you'll be looking at for this recitation specifically is just like the squared equation, the p squared plus 2pq plus q squared equals 1.
Okay.
Um yeah, but this specific I yeah, this the population genetics definitely isn't my strong suit, I'll say.
Okay.
But overall, let's see here. If I remember correctly, I don't remember there being like too many questions on the exam about these specific equations. I don't know if my ATAs agree with me or not, but yeah.
I know
There's like,
the one that's in the concept quizzes
Yeah.
um is is actually a bit different than this one, but I
yeah.
never quite understood why, like how you're supposed to know.
Right, right, yeah.
But
So
yeah,
it's based off looking at the equations and the numbers. So basically, it's looking for the heterozygous. So we know that. Okay.
Yeah.
So it's giving you the equation, which it's we know that the heterozygous is always 2 times PQ. So what we're doing is because we have the two different islands that are here, you're basically taking the 0.42 and the 0.42 and inputting it in there for the 2PQ or the PQs that you see in the top equation for H. Um, and then what you're going to do for that is that you're going to like average them. So basically, you're still going to just average and you're going to get 0.2. The reason why you're going to calculate the FST is because you want to know like the rate or like how the population is changing based on this Walland effect. So it's kind of like it, you just have to know what the variables are representing and what you have to use in order to solve the equation, if that makes sense.
Yeah. So that's what I tried to do.
Okay.
Um, for the concept quiz. Do you mind if I pull up the concept quiz actually? I think I have a picture of it.
Yeah. You, if you, yeah, if you do, because
Yeah.
the Smallland effect is a little confusing.
It's very, very
If you
confusing.
email her too before
Yeah.
her office hour today, she
Yeah.
may be able to include this in her office hour.
Okay.
Yeah,
Do you think I can also ask her at the end of the office hour if she doesn't go over this one?
you could. You can also email her too.
Okay.
I know we are going to go over it in the ATA exam today as well.
Okay. Okay, maybe
So,
I'll just wait till then and see.
yeah.
Okay, all right. Thank you.
Hmm.
Liana, I was looking at the concept quiz problem number one, the Walland effect, right?
Exactly. Yeah.
So they give you two populations. So you
Yep.
take the average of the, what is that, 0.18 and 0.50, the heterozygous
Yep. I did that. Yeah.
0.34.
Yeah.
Then you have the P1. So you take 0.81, that is the dominant allele frequency of the population one, that is 0.81 plus you take the half of the heterozygous one, right? So it's 0.18 divided by 2. So those two add up to the allele frequency, that is P1.
Huh.
So that's how you find the allele frequency of P1 and Q1. Similarly, you do that for P2 and Q2. You take the averages of those two, that will give you individual P and Q. Let me put it in the chat if you just wanted to. So P1 is nothing but allele frequency of the dominant one plus half of this. Then Q1 is the same thing. Q1 is the recessive one, allele frequency of recessive one, and plus half of the heterozygous.
Okay.
So that will be equal to, so for P1, you would get 0.81 plus 0.09. So which is equal to 0.9.
Okay.
And
I think if you look at our ATA exam review questions,
Yeah.
that question it's similar, is in the slides.
Okay.
I was
Okay.
just
I
looking at
guess-
it right now.
Okay.
So, yeah, if
Okay.
you check
I'll
the-
just wait till then. Thank
Yeah,
you.
if you check
Yeah.
the Canvas message that I sent out yesterday, it has the PDF of all the slides. So
Yeah.
it kind of has a step-by-step on how to do the Walland effect too.
Okay. Sounds great. I'll check it
Yeah.
out. If I have any other questions, I'll just ask during the review. Thank you.
Perfect.
Yeah, that stuff's confusing. Thank you guys. Walland effect. All right.
It's always that and identity by descent always confuses students too.
Oh, definitely. Yeah, I don't think I've reviewed those parts of the lecture quizzes ever, or like ever had to. Like no students ever brought that up. So thank you, Janina.
Mm-hmm.
Are there any other questions about any of the concept quizzes or anything before we go over recitation number 6?
my only question is, so Luke, about the variance, right? The last one of the concept quiz.
Oh, definitely.
So the question is, I know what to do, but how? I hope this question doesn't arise in the exam, because this definitely requires a calculator. So concept quiz 5, quantitative genetics, problems Q3 and Q4. So question number 3 and question number 4, we cannot do that without a calculator.
Definitely. If you have it up right now, would you mind sharing your screen? Or I can bring it up too.
I don't have that ready. Sorry.
No, that's okay. Which module and concept?
Fine. So module 4.
Uh-huh.
Sorry, module 5. Whatever the last one, right? Module 5, quantitative genetics.
Okay. Let me find that real quick. But you're right. A lot of these numbers can be super, I don't know, or
Even the
not
square root,
whole. Uh-huh.
we can estimate the square roots, but
Mm-hmm.
if it's very close, then it's going to be a problem, like one of the problems in recitation 6, right?
I see.
Question 2, if you take the square root, you're going to estimate question number 2.
Okay.
So it's like you can.
So the numbers you see in your concept quizzes and on the activities they're harder and bigger, so you understand the concept when you see it on the exam. So when she goes over like activity, I think it's 4 or 5. I think it's 5 where you
5,
do,
yeah.
it's 5 where you
Mhm.
have to do the square roots and everything. She shows you how to do that without a calculator. Same with like question 5. It's just to see if you understand the concept more than actually having to see it on the exam and without doing it on a calculator.
Yeah, question 5, we don't need a calculation, but question 4 and question 3 and 4, we definitely need calculators because I mean, it's not like we can do without a calculator, but it's going to be time consuming.
Definitely. Yeah. Yeah, I
3 and
agree.
4. So it's like you take the, like you multiply the individual Brisson number with the frequency, which is number of individuals, and you divide
Mhm.
it by the total number of individuals, which is 564 divided by 120. So you get
Yeah,
4.7. So that at least I can say I can finish it in 2 minutes. But then, but question number 4, it's a lot of error prone because you have to subtract, then square them, then multiply them, then divide them.
definitely. I see, yeah, yeah, I see the worry too. I would be surprised if the numbers are as difficult as they are on this concept quiz as they would be on the exam. You
Mhm.
should be able to do the math in your head on the exam or just on like a scratch sheet of paper.
Okay. Okay.
Yeah,
Okay. Sounds good.
definitely. Yeah, because when it comes to especially variance, you're right. There's a lot of room for error when you're trying to
Yeah.
use numbers like this
Right.
um
And
with
one more
scratch work.
question, Luke.
Hmm.
So I mean, in general, Dr. Holchek is, syllabus said you had 35 questions and one essay question, but I had 37 questions and one essay question. Is this how it is, like for different versions?
If you look at
Um,
her announcements, it says how many questions are on each exam.
Okay.
Yeah,
gotcha.
her one that just went out Saturday has how many questions are on exam two.
Okay. Okay. But even that is, it is with and without accommodations. Is that what it is?
Yeah, it's the same even with accommodations, I believe.
Okay.
It's just the time frame, I think, and depending on the accommodations, how she changes it.
Okay. Okay. I get. Okay. So yeah, this module 3 and 4, they are challenging, very challenging. I think they're all brain teasers. Yeah,
Definitely, definitely. Yeah, yeah, the population genetics is super tough, I would say.
yeah. The critical value, those things. I mean, I think even activity 5 is manageable, but the concepts like when you have to think about again IBD, and you have to look at genotypes and allele frequencies and take the square root and all of that. We got to be very careful at this.
Definitely, definitely. Yeah, I mean, if you have any other questions leading up to the exam too, just about yeah, whatever, just make sure you reach out to us also.
Sure, thank you,
Yeah.
thank you. Look, you have seen my emails. I always bother you.
No, that's okay. That's okay. I was out of town last week, so I was a little delayed in responding, but um yeah, I'm always happy to help.
Oh, thank you so much.
Yeah, of course.
So we are ready for recitation 6, if you're ready.
Awesome. Okay, let's do it. Does anyone else have any questions about concept quiz stuff? Awesome. So anyways, in terms of recitation 6, I mean, we were just talking about what, like wall-end effect, all of these, means and variances. Recitation 6 is solely about Hardy-Weinberg equilibrium.
Mhm.
So looking at question 1, just to kind of start off the concept quiz or the recitation quiz, which of the following are assumptions of the Hardy-Weinberg equilibrium model? Mark all the correct assumptions. So you'll find that there's a few possible options
There are
out
three
of these 5. Yeah,
3 will work. Yeah, I don't have questions on that. No questions on the first.
gotcha. Okay. And then I was looking at the recitation quiz and I noticed that these pictures are showing up kind of weird for me. So let me know if it's the
Yeah,
same for you guys.
I think the 2 cats are missing. Yes.
Definitely. Yeah. Yeah. And that's unfortunate too because they were cute cats. When TA Mario was showing us what he had created for this recitation. So I'll see if he's able to change it, but I think since people have already taken the quiz, we're not able to.
Right. And see, in this problem, right? So we are, in order to find Q, we take the square root of 240 divided by 900, right? So,
Correct. Yeah.
okay, so we can divide and we get 0.267. But the
Hmm.
square root of 0.267 is where you got to estimate between the two numbers, right? Which is between zero point 0.4 and zero point 0.5. I mean, zero point 0.5 and zero point 0.6. So that's where, like, closer to, because your answers, I mean, thank goodness in this, it's when you get a q as zero point 0.5, right? Closer to 0.5,
Hmm.
and you subtract that from 1 to get p, which is zero
Hmm.
point 0.5 again, which is closer to the 0.484. So p is 0.484.
I see. Okay, yeah. So if you want to train yourself to be able to do it on like a scratch sheet of paper, then yeah, I'd say that's about correct.
Yeah.
Like
So
like the correct line of thinking of like almost estimating.
yes,
Yeah.
but if they are very close, then we are in trouble.
Yes, yes, which on the exam, it's possible for them to be pretty close because um, the exam questions are worth a lot of points.
Yeah, yeah. So that's where I'm a little bit,
Yeah,
because that is, I mean, it's not like we cannot do it without a calculator, but it's time consuming. Maybe we have to get a golden ticket for that.
definitely. Okay. I mean, I'll double check with Dr. Holacek, but instead of it being 240 over 900, I think it would be more like, 300 over 900, something that's a bit more like a bit easier to calculate quickly inside your head and then to take the square root of.
Right, right. So I mean, am I on the right track? Is P equals 4 point, I mean, 0.484 on that?
Yes, yeah, you're on the right track with that.
Thank you. And similarly, we do problem 3. So problem 3 is similar to problem 2, just the numbers have been changed.
Correct.
Oh,
Yes. Yeah, so when you're looking at yeah, obviously you're given what Q squared here, so then you're able to find
right. So that will
the
be recessive. So you find Q, that will be the recessive one. And
correct.
and then you 1 minus Q, that will be P. I mean, I'm just talking, I'm sorry, Liana, I mean, I don't know if anybody else wants to talk. I'm sorry.
Yeah, exactly. Liana and Candace, if you guys have any questions as we go, feel free to chime in.
Yeah, for questions 2 and 3,
Hmm.
so few questions.
Hmm.
So whenever we know this population is in Hardy-Weinberg equilibrium, right?
Hmm.
So when we know that and we're given the numbers such as dominant is 660 and recessive is 240,
Yes.
we know that that's p squared and q squared.
So these are actually the dominant and recessive phenotypes, and the dominant phenotype consists of the homozygous dominant
Yeah.
group, which is p squared, but it also contains the heterozygous group, right? Because someone containing one dominant and one recessive allele is also going to have the dominant phenotype.
Okay.
Yeah.
So that's where my second question is. I was like,
Hmm.
why do we have to find q first and not p? So I guess that makes sense.
Yes, for these questions, you're pretty much always going to have to find Q first because you
Okay.
won't be able to find P based off of, P squared plus 2PQ because you have both P and Q as variables.
Okay, but looking at these questions, we know 240 is q squared, right?
Yes,
Oh,
correct.
okay.
Correct. And then
And-
you're going to find the same thing on question 3.
Yep. Okay. Okay, that's helpful. Thank you.
Yeah, yeah, of course. Okay. But yeah, Lakshmi, you're going to come down here and pretty much do the same thing on question 3 as you did on question 2.
Right, right. Okay.
Awesome. So then looking at question 4, so looking at this question, you're actually kind of given P squared and Q squared right off the bat because the allele for big A is codominant with the allele for um, big D. So when you're given the proportions down here for big A, and big D, you have pretty much P squared and Q squared. So this one's a bit easier than questions 2 and 3.
Right. You just take the square root of those two and you have it, right?
Yes, yes, correct.
Okay. And
Hmm.
is there a second way to solve this where you calculate p? So the way I did it was I did 2 times to calculate the frequency of big A, I did 2 times 0.36 plus 0.48 over 2.
Oh, I see. That's another equation that you guys are given, right?
Yeah, but can I also use that to solve this?
So, sorry, you said 2 times 0.36?
Yep. So 2 times AA plus AD over 2.
Okay. So what that would give you like 0.72 plus 0.24. That'll probably give you a different answer.
Really? I mean, I got point 0.6. I don't
Oh,
know
you
if that.
did? Okay. Oh, actually, sorry. I was just trying to do it in my head real quick, but if you got zero point 0.6, then yeah, I guess those equations lead to the same answer here.
But you're saying it's 2 times 0.36?
Yeah,
Uh,
basically 2 times big A plus AD.
that's when you have we have to separately calculate allele frequency. But the problem here is the allele frequency are already given to you. So you just put 0.36 plus you divide the 0.48, right? Divide by 2, which is 0.24. So you add them up, you get 0.6 if you want to do that way.
Okay, I see. So it's just one big A
Yeah,
plus half of AD.
yeah, because the frequencies are already given to you in terms of decimals here.
Uh,
So I guess if you were given the frequency of, wait, no, that doesn't make sense.
and where are we getting this formula again? The AA plus half AD.
There is a formula sheet when you go to the, I mean, recitation or anywhere, there is a formula sheet attached.
Yeah, I have that open.
Yeah, if
Yes.
so, if the frequencies,
I see.
if you have to calculate the genotype, I mean, if you have to calculate the allele frequencies from the genotype, then you do 2 times AA. Otherwise, you directly take them. You don't multiply 2 unless. So you have this formula sheet. Yeah, another one. I mean, there was a formula sheet in this PDF. In this,
Gotcha.
Yeah,
uh,
that's what I have open. Yeah,
Okay.
and I can
you look
see
at the
that
so
yeah.
look at the top. So it says P equals frequency of AA plus half frequency of AA. This is when you are given
Yeah,
the frequency.
I see. Okay. Okay, that's helpful. Thank you.
Yeah. No problem.
Perfect.
Because it tallies with your square root of 0.36, which is equal to what you would get when you do this calculation. So there are 2 ways to do this.
Yeah, that's helpful.
No problem.
That's much quicker too.
Yes. I mean,
Definitely. Yeah.
Luke said in the beginning, right? See, AA is 0.36. Each one of these categories are already given to you. So P square and Q square are directly given to you. So you just have to take the square root of those two.
Yes,
And then
precisely.
these formulas are not going to be given in the exam, right?
I don't believe so. So I would recommend just making sure you
Okay.
know them so you can refer to them if needed. Okay. Good questions, y'all. So looking at select the correct order of steps in statistically testing a hypothesis. You'll be kind of matching 5 steps and hopefully getting the correct order for all of these. Um, which I believe you'll be able to get this from either the lecture videos or from Mario's video for this recitation.
So I got everything. I just wanted to confirm step 2 and step 3. So step 2 will be calculate the test. I mean, calculate x squared, the what is it, chi-square value, right? Step
Okay.
2.
Mm-hmm.
And step 3 will be calculate degrees of freedom.
Gotcha. I can double check real quick.
That's what I have too, but I wasn't able to.
Yeah, I'm almost positive that you guys are on the right track, but I just don't want to make sure I give you guys wrong answers because this is like a pretty important part for getting this statistically or like statistics tests right, you know. That was hard to say. So let's see.
It's
Presentation.
Monday. We probably still all haven't had our coffee yet.
Oh, I know. I'm like actively drinking mine and it's not working.
My ice is still being made, so I can make my iced coffee. So I haven't had mine.
Nice. Okay, so that's gonna be question. Okay, right. And then you said what was your step 3 again?
Yeah, step 3 was calculate degrees of freedom.
Right, right.
And step 2 was calculate the chi-square, x square value.
Yeah, you guys are definitely like on the right track with that. Like
Thank you.
the overall, yeah,
Yeah.
workflow of it. Awesome.
My I have two other clarifications, but I will let others go before I ask.
Sounds good. Okay, I'll continue on to question 6 then. So assuming that the p-value is 0.05 and you have 1 degree of freedom, what's the critical value that you'll compare your chi-squared to? So you're literally just going to use the 0.05 column here, and then just use the table to see what your critical value will be with 1 degree of freedom. So then question 7 is an example of like a result you might get. So you're looking at a population's genotype frequencies, and your resultant chi-squared calculation is higher than the critical value set on the chi-squared distribution table. So that's the one you got from like question 6, for example. What can you say with 95% certainty? Here you'll be able to kind of get practice with seeing what like a conclusion would look like um, in this scenario, which I think you'll also get. I think it's activity 5. You'll get practice with something like this also. Then question 8, true or false? In nature, populations are not always under equilibrium. I hope that's straightforward because in nature, there's a lot of other factors that go um, into population genetics. And then question 9, calculate the degrees of freedom for blood type in humans, the system ABO, using this formula. So the formula is given to you. You should be able to find the number of genotypes. And then here, it kind of tells you that there's 3 different alleles.
So this is my question. So the genotypes, are
Mhm.
there 6 genotypes that we are talking about?
Right. So thinking about the ABO system, what you have the
A,
allele for A, allele for B, and then the allele for O, which is little I.
uh, hmm.
If you remember like the blood type example, I think it was from recitation 4. Was-
Right, but see, when we say allele for A, B, and O, then it's 4. But if I mean, but there can be AI too, right? A and and
yes.
I, and then you can have I, and you can have
Hmm.
A and B. So and AB. So together there are 6. Am I right?
Right, right.
Okay. So 6 minus 3 alleles.
Correct, correct. Yeah, so that's how you'll find degrees of freedom for a system like this. And then looking at question 10, which of the following situations will change allele frequencies from one generation to the next, thereby breaking Hardy-Weinberg equilibrium? So you'll just select the best possible answer from these 4
So
scenarios.
yeah, so I have a doubt. I mean, I'm struggling between the two choices. A dominant allele confers a markedly higher survival rate, and then
Hmm.
large numbers of immigrants bring new alleles into the population. I know the last one. I mean, that is gene flow, but the dominant allele is natural selection. So which one do we eliminate? So that's my question.
Right. So with gene flow, the way I like to think about it is like because both honestly would probably play some role in breaking Hardy-Weinberg equilibrium, but if new alleles are introduced and one doesn't have like a markedly higher survival rate than the other, then Hardy-Weinberg equilibrium, in my mind, will kind of be rebalanced.
Mhm.
So whenever I'm looking at this, uh, the dominant allele one usually sticks out more.
Okay, okay,
Yeah.
that's good. Awesome. Okay, so I think these are good practice examples. There are a lot of questions that come up. Yeah, very nice. Thank you so much.
Yeah, yeah, of course. Leona or Candace, do you guys have any questions?
I'm good. Thank you so much.
Yeah, yeah, of course. Yeah, the questions towards the end of this quiz are a bit easier than the equation questions up here. So kind of get the hard ones out of the way first.
So do we see you again on Wednesday for recitation 7?
Yes, yes, you'll see me on Wednesday. Last week I just had a meeting conflict, so
Okay.
this week I will be here on Wednesday again.
Okay.
But yeah, like I said, feel free to email me or any of the other TAs.
Okay.
As you saw today, the ATAs are like have a lot more experience than me in a lot of the different areas of this class. So feel free to ask them as well. And
Sure.
then yeah, if you guys don't have any questions, you guys can head out. We're just gonna hang out here for or until the hour's up.
Okay. I have a question. So I finished activity number 5, but my only question about this activity is the last 4 questions that we have, the question number 3 that we have to fill it in. If these results could be explained by individuals moving in and out of the population, which evolutionary force is this referring to?
I
I
see.
gene flow. I don't know if I'm right.
Let's see here. I'll actually pull up. This is activity 5, you said?
Yeah, activity 5.
Okay. Yeah, let's look at it. Right. So if I remember correctly, this last question you're saying down here?
The third one, the one,
Gotcha.
yeah,
Yeah, so you're just going to want to mention what's the word I'm thinking of?
assumptions which are not right.
Right, right. Yeah, 3 factors that would lead to a population not being in Hardy-Weinberg equilibrium.
Right, and I'm talking about the one before, not question number 4, question number 3.
Oh, I see. I see. Sorry.
No,
Um, right. So yeah, you're on the right track with thinking that is gene flow.
okay, awesome. Okay, that's it. That's what I had the question on.
Gotcha.
I finished recitation 7. I don't know if it's too much here.
No, you're good.
I'm taxing you with a lot of questions.
Yeah, that's okay. It said recitation 7. Let's see. Selection and fitness. So I will say this one I haven't looked over much, but we can look at it still.
No problem. I mean, I can always, email you with my answers, and or I can pop up during your office hours on Wednesday. No problem. I
Okay.
just one confirmation question on question 10 in recitation 7. Um,
Okay.
so I'm looking at the table, right? So the question says, based on these numbers, which phenotype of the giant turtles does natural selection favor in this environment? So we are looking at every single row, right? So the N1
Okay.
current frequency is 0.430, but the expected future frequency is 0.427. That means it's going down for both first row and second row, but the third row it's increasing. Is that how we look at it to answer this?
That is a good question. Show the current expected future frequencies. Oh, I see. So you're saying in the future, the frequency of N1, N1 is going to be lower.
Lower, and N1, N2 is also going to be lower. So
Okay.
N2, the long necks are going to survive.
Right. Okay. Yeah, you're on the right track for that one, just because, yeah, what does natural selection favor
Favor.
in this environment? Yeah, right. So if the expected frequency of a
Mhm.
certain allele combination or phenotype is going to increase, you could say that it favors, yeah,
Oh, awesome.
it's being favored.
Thank you so much, Luke. That's it. So
Of
see you on.
course. Okay, that sounds great. Yeah, thank you for all the questions.
Oh, bye. Thank you.
Bye. Candace, do you have any more questions about, we can go back to recitation 6.
I guess I'm just confused on like which formula to use and when.
Gotcha. So, looking looking at questions 2 and 3 specifically, even 4, um, you're given like phenotype numbers. So specifically what 660 for the dominant phenotype and 240 for the recessive phenotype. Whenever you're given numbers for phenotypes, you're usually given Q squared, which is this, right? Because it's going to be homozygous recessive.
Okay.
So my suggestion is always use the simpler formula, which is just the square root of Q squared is Q. And then from there, you'll be able to find P, right? Because P plus Q equals 1.
Okay.
So that's what you're going to, I think that's the only equation you'll be implementing for this recitation. For other questions, here, let's pull up it would be easier to pull up the formula PDF because I'm honestly not familiar with all of these equations.
I think I'm just worried about like having to remember them on the exam, and like I'm just I'm a kind of like a visual person, for me like remembering what to use and when to use it is kind of going to throw me off.
Hmm. Oh, definitely. I mean, all of these, so let's see here. So yeah, we were just talking about this one. Oops, the special case. But looking up here, I guess you would just have to be familiar with these equations and then based on what information you're given in the question, be able to use those numbers from the question to kind of just plug and chug in these equations.
Right.
Yeah, because I mean, these P and Q equations seem helpful, but if you're given the frequency of big A, and then big A, little a, you're probably given the frequency of little a, little a. So you would just use this simpler one at the bottom.
Okay.
Down here for genotype counts, though. Okay. So you're actually looking at the number of individuals with a certain phenotype. I'm not sure. Maybe my ATAs know more also. I'm not sure if there are many questions that use these specific formulas here.
There may be one or two. There is one that uses the those two formulas on the exam practice questions, and I think we go over it in the ATA exam review. But you won't see a lot of it. The reason you'll use these ones if you're trying to find the specific frequency of, let's say, the dominant A allele or the recessive A allele. So that's why you have the two, like P will equal 2N times the homozygous dominant, is because when it's asking for the dominant allele, remember the homozygous has 2 copies and then your heterozygous has 1 copy. So that's why you're going to use the 2N. And then your 2N is the total number of the population because remember, you always have 2 alleles in the population.
Right.
So
Okay.
that's when like you're looking for specific genotypes, is that's when you would use those equations for P and Q. It's knowing keywords.
Right. Right.
So like genotypes, okay, you're going to use the P equals 2N of homozygous dominant plus N of heterozygous all over 2N to find P. And then once you find P, you always know that P plus Q equals 1. So you don't even have to do the second equation for
Right. You just
Q.
subtract it.
Yeah.
Right.
So it's just looking, I always say look for keywords. So what I would do too, if you're having trouble of understanding what equation to use, is look at the questions that give you this, like you use the specific equation and then write keywords. So when you get to the exam, if you see that keyword, you know, oh, I need to use this equation.
Right. Okay.
So that's kind of like how I do it. And that's why we're doing the exam review today instead of like tomorrow or Wednesday. So it gives you
Time.
3 days to review our exam review before the exam opens on Thursday.
Right.
So, and a lot of us will have like tips and tricks on how we solve this as well. And I think they're also in, like, it shows like each concept of when you would use a specific equation in our ATA exam review slides. I have them up, but I have to go review them again.
Okay. Thank you so much.
Yeah, you're welcome.
Yeah, of course. Great question. Thanks, Jonina.
You're welcome. Surprised I'm functioning right now.
It sounds great. It sounds great. Yeah, a lot of equations for this part, but guess it all makes sense. Dang, 33-minute video? That's crazy. Sorry.
Yeah. Oh, it's always insane. There's so many equations. But like I was sitting here thinking after I said looking for keywords, like if it's asking you to look for genotype, you should know that that's the alleles, like homozygous dominant, heterozygous, and homozygous recessive. So that's kind of like, okay, that's where you would use that P equals the 2N question as well, because that's kind of like bringing back from your memory from modules 1 and 2 of what alleles are and genotypes are.
That's true.
I was like sitting here, I'm like, wait,
Gotcha. So if it's asking for all three genotypes,
yeah.
then it would be helpful to do that. Okay.
But yeah, it's always if you find one, you always know it equals one, so it's easy to find the other. That's the one best thing about P and Q.
That's true. Yeah, it's just the method of finding the first one might be different in certain
Yes.
And
scenarios.
then what time is the review tonight? Because I just have to figure it out because I'm on New York time.
It's 4 p.m. Arizona time, but it's gonna
Okay.
be recorded, and I should hopefully have it posted tonight. Like I
Okay.
think I posted the last one around like 9 p.m. So if you
I'm gonna try to
can't,
be present for it just so I can ask any questions that I have. I guess that I'm just on New York time, so I just
yeah,
have
no,
to.
so it'll be 7 your time.
Okay. Thank you so
Yes.
much.
Yeah, that review is definitely helpful, I'd say, in preparing for the exam. Super
And this
helpful.
one's typically the longer review. Like this one's like a 2.5 hour typically.
Oh, wow.
Because you have chi-squared, you have Hardy-Weinberg, you have Walland effects, you have all the this like math.
Yeah.
Exam 2 is math heavy.
Oof. And yeah, when it comes to genetics, that's not that fun.
So, yeah, like we have, oh yeah, and then it goes over like all the gene action stuff, gene mapping, slash notation, modeling selection, genetic drifts. Yeah, so
Yeah.
it's fun.
Yeah. Yeah, population genetics is a doozy.
That's Dr. Holchek's like favorite. She loves population genetics.
Yeah. I mean, it's super cool, but as someone who like never studies it, it's feels kind of crazy.
No, I don't know. I can't decide like what is harder, this or Lac-Operon.
Yeah,
Yeah.
like Operon, I still don't get like
You
at
know
Right.
all.
what? After being an ATA for 2.5 years, I actually like started finally understanding it like 2 semesters ago.
Nice. And then how many rounds of Black Operon was that? Like 10
Let's see,
or 8?
I took genetics summer of 2023. So that was 2
Okay.
years ago. And I've been an ATA since fall of 23. It's a lot.
Okay. Yeah. Yeah. That's awesome. Yeah, Black Operon's just
So
so
maybe
yeah.
if I keep doing this until 2027, maybe I'll get it.
Maybe.
That's what it sounds like. Yeah,
I
maybe.
mean, it really actually like it's not really that hard to understand. I think it's just because there's so many different components to the Lac-Operon.
There was something to me that just felt like backwards. You know, like
Yeah. No,
like
no.
yeah, like I would like come up with like the answer that was right in my head and then just mark the other answer, like just
I agree. Oh my gosh, that was so hard for me.
That's the concept that everybody struggles with. Everybody. Like
And I think it being like at the end too, you're just like, oh my God, like I just can't even. Like I was just like winging it at that point because that was the one topic that I just like could not grasp.
yeah, same, same. But the math actually surprisingly, every semester that I've ATA'd for this class, exam 2 is actually everybody's like higher grade. Like people
Yeah.
get a higher score on exam 2 than they think they will.
Yeah, exam 3 was my drop.
For final was mine.
Yeah, I didn't do the final, I don't think. And I don't like to tell people that, but I had an A+ already, so I was like, I'm not taking the final.
I took the final just to see because I think exam 1 was my lowest, but I ended up being like 1 point lower because I was just like, all right, let me do it. But yeah, I took it just to see if I could get the higher score to improve my grade. But yeah, so we'll see. But yeah, the tonight's exam review is going to be like 2.5 hours. Maybe. We'll see. Depends on how quickly we can get through. Candace, I would say if you can, go through the slides that I sent
Okay.
and just kind of review everything. And if you, that's one, like if you have any questions when the ATAs are going over, you can pop it in the chat and one of the other ATAs can also answer too.
Okay.
Yeah.
All right. Thank you.
Mm-hmm.
Yeah, of course, Candace.